All right, guys. I know we're sharing a lot of information, a lot of details. Hopefully, you guys are enjoying it. So, one thing, just based on some comments privately I've seen, is that so far we are not talking about Aviatrix, right? So this is just Cloud 101, just focused on everybody understanding the basic construct. So when we talk about the challenges in the cloud, you know what they are related to, right? So it's going to be short in Google Cloud because a lot of bases that we've covered around accounts and VPCs and stuff are very similar. So we'll call out the differences and we'll focus on that. So similar to other constructs in AWS and Azure, you'll see that in GCP, you have something called either products or services. So networking is a service, compute is a service, all of these things are a service. And within these services, you have a specific resource. For example, for compute, a VM is a resource, a disk is a resource, image is a resource. For networking, there are different networking services that you have VPC networks as a resource, IP addressing, and firewalls and load balancers. So all of these things are resources. So again, going back to the Lego pieces thought process, right? So these are all of the Lego pieces that you have to put together. So that's one thing. And then how are you going to have visualization? How are you going to be able to see how these things are connected to each other, right? How are you going to do troubleshooting? That's a massive problem that comes because of the way these constructs are built from a Lego pieces perspective. So now let's double click on the resources aspects, right? So you have the resources in 3 different categories in GCP. You have some things that are global, something that are regional, something that are zonal. So something which is zonal, as an example, would be a VM or a disk, which is specifically available to us, a zone, availability zone. So for example, in here, this is something that's available in this specific availability zone only, right? You have this VM or disk. Then you have regional constructs that are available by any resources in the same region. So for example, an IP address, right? So the IP address can be available in zone 1, zone 1A, 1B, 1C, 1D, whatever, right? But it has to be in that region, right? So central US, that specific IP won't be in, let's say, US West as an example, right? Then you have global resources, things that are available across all the regions, right? And one example of it is some of the networking services like VPC. So before we go into the details of networking, we need to understand what's a project. So if we look at this from this diagram from a bottom-up perspective, what you have is, let me grab my page. Okay, what you have is the resources at the bottom of the tree. So these are like VMs and things, and these things are inside a project. So when you go and you create anything, you will have to create inside a project. So if you have your own personal account, you will start with defining a project. And once you have a project, everything that you create will be inside this project. For example, this is a test VPC project, and all the resources are inside this test VPC project. The other other stuff in different projects have no access to stuff in this project unless you have a concept of shared VPC or network peering, where you as a project owner, and let's say me, I have a project and Brian has a project, and we build some rules and stuff and build peering and allow our instances to talk to each other. Then you have concepts of folders and organization. This is only available if you are using AWS organization concept. By default, GCP organization concept. As a single user, if you just go and sign in, you will not see these folders and organizations. But if you sign up for a G Suite and you go from that perspective, then you will be able to set up these departments and teams and products and whatever folder you want, and then you can have multiple projects inside of those. So now that we understand the basic building blocks of GCP, let's look at the networking pieces of GCP. So the first thing is the VPC in GCP is a global resource. What that means is once you create a GCP VPC, it's available in every region. You don't have to go in and create a new VPC in a different region and manage connectivity between them, right? So when you create a VPC, let's say, and then you create multiple subnets, you can create one subnet in US West and another subnet in US East. And there's an implicit router which you don't really see, which will do routing between these two subnets, irrespective of the region they are, as long as they are part of the same VPC. Then you have the concept of VPN gateway. It's the same thing as others. It's just a VPN endpoint for you to connect your on-premise location. Then you can do connectivity between these, and then if you have multiple VPCs, then you can do VPC peering. It's exactly the same concept. However, the important takeaway here is that you will notice that every cloud provider will play to their strength, right? So GCP's strength is this global VPC that they can have a subnet in West and East, and without customer having to do anything, these things are routable between each other. However, if you have another VPC, right, and you have some subnets or instances here, the global routing does not route between these two VPCs. You still have to use VPC peering to peer these VPCs one-on-one. So if you have 100 VPCs, you peer them one-on-one. So the same limitations as other cloud providers still apply here, but because they have the concept of global VPC, GCP tends to always ask people, why do you even need multiple VPCs? You can just have one VPC and put everything, all the eggs in the same basket, essentially. So, and there's a lot of limitations and problems around that, and we'll see some of that later. Okay, so now let's look at the next step that, similar to others. You can have the VPN gateway to connect you to on-premise, and you can have access to the internet. There's no concept of private or public subnet. You just give a public IP, and then your instance is off to the internet. There's a default route which says 000 out to internet from the VPC. So as you can see from security perspective, this is not very ideal. As I mentioned, VPC is a global resource. All the subnets are inherently routable within a VPC. I mean, sometimes it may look like a good thing, but at other times this is problematic because you have no control, right? If you wanted to say, hey, subnet 1 can talk to subnet 2, subnet 2 can talk to subnet 3, and a lot of reasons to do that, maybe around GDPR or other reasons why you want the stuff in one region not to be able to talk to another region. So those are the kind of things that you do not have any control over. The only option that you would have is to spin up more VPCs, but then GCP doesn't give you any way to connect multiple VPCs except using VPC peering. So when you have a VPC network, you can create subnets, right? So there's no concept of a VPC level seeder. Like in AWS, we saw that you create a seeder 10.0/16, and then you go and say 10.01/24 is a subnet 1 and subnet 2. There's no such thing here. It's just, a VPC. There's no high level seeder. You can create a subnet basically from any non-consecutive ranges. You have two different ways of creating the subnets. You can do an auto mode or a custom mode. Auto mode would automatically create subnet in each region. Custom mode means it doesn't create a subnet in each region, and you can choose which region you want to be in. So for example, in here, the default is auto mode. That means, there's a subnet created for you in each region. But if you are in the VPC network 2, use Asia only, so it's custom mode. That means you're not spinning up subnets in every region. Routing in GCP, when you look at the route tables, you have two kinds. You have system generated routes and then you have custom routes. The system generated routes give you default route, which is, as I've mentioned earlier, is a 0, 0 route to the internet right away. And then you have a subnet level route, which allows traffic between the subnet ranges to go with one another. So again, this is limited within a VPC only. Then you have custom routes where you can define custom static and dynamic routes. The static route, the next hop has to be an instance by name or IP address or a VPN tunnel. And you can do dynamic routing, which is via BGP. Now there's another concept, and we don't have time to in associate to go and deep dive, but it's called cloud router within GCP. The cloud router is a control plane entity that does the BGP for you, but the data plane is run by the underlay on its own. So cloud router is just a control plane entity in GCP. And if you have to do networking in GCP, and especially with their interconnect, you will heavily use the cloud router. Now, for the inter-VPC networking, there is no solution from GCP. So again, they play to their strength saying, hey, you don't really need multiple VPCs, and you just need one VPC and you can put everything in it. But it becomes problematic because then it's hard to put controls, it's hard to put security, it's hard to put routing and firewall rules and everything. And VPC peering has same limitations as we have seen from others, and it's non-transitive, and you have to build a full mesh yourself. Their equivalent of connecting your on-premise to the cloud is called Cloud Interconnect. So it's the equivalent of Express Route from Azure and Direct Connect from AWS. And you can buy 10 gig or 100 gig pipes to connect, and you use the same connectivity provider like Equinix and CenturyLink and so on and so forth. You can have a dedicated interconnect, and the way it looks, and this is very similar to the previous diagrams, this is your on-premise and you have an on-premise router. This is the point where you have some kind of provider providing you connectivity between your location and a data center where Google has presence. And once this connectivity is built, then you connect to the cloud router, which is the control plane. This is where the BGP sessions are running, right? And then the traffic is routed from the compute down in here.